Okay, we talked about weak acids and bases in grade 11, but now that we're doing equilibrium, I think we can have a better perspective on what's really going on with a weak acid or a weak base. A weak acid or weak base, we said in grade 11, was one that does not completely react with water in the acid-base reaction. But now that we consider the forward and reverse reactions, what we really mean by a weak acid is a weak acid is one in which an equilibrium is formed where the forward reaction and the reverse reaction are both occurring at significant rates. Let's look at a couple of a weak acid and a weak base, and we'll see what we're talking about. So a weak acid, hydrofluoric acid, could react with water. Remember, an acid is a proton donator, and so what that would mean then is that it would donate its proton to the water, making hydronium, or H3O+, and as a result it would form its ion. All of these things are aqueous, except of course the water, which itself is the liquid or the solvent. What we're saying then is what makes HF a weak acid is that water sometimes will give that proton back and it will reform into HF and H2O. So both the forward reaction, where fluorine acts as the proton donator, and the reverse reaction, where fluorine acts as the proton acceptor, occur at significant rates. In this case, this HF is acting as an acid, and the water is acting as a base, a proton donator and a proton acceptor. And in this case, in the reverse reaction, fluorine is acting as the proton acceptor, and so we call him the conjugate. Conjugate just being our code for reverse base. And we call H3O+ our conjugate acid, where now H3O+ is donating its hydrogen back to fluorine, so it's acting as the acid, and fluorine is acting as the base receiving that in the reverse reaction. That's what those conjugates mean. Let's contrast this with a strong acid like HCl. HCl in water will form H3O+ and Cl-, and basically the same reaction where the H plus, or the hydrogen ion will be donated to the water to form the hydronium, and the chlorine will exist on its own. But the reverse reaction doesn't occur, or doesn't occur enough that it's important. So that's what makes this strong. So if the reverse reaction doesn't occur, it's strong. If the reverse reaction does occur, then that's what makes it weak. What that means then, because both the forward and reverse reaction happen, you will not get not as much hydronium, where since only the forward reaction happens, all HCl is converted, or it is used to make, I'll say is converted, is used to make hydronium. Same thing can be said for bases. Again, another example of a weak base is ammonia. If ammonia is in water, it can take the hydrogen from water and will act as a proton acceptor, or a base, and the water in this case is acting as an acid. That creates ammonium and hydroxide. But the reverse reaction also happens in a significant rate. The ammonium will give the hydrogen back to the hydroxide, recreating water. So this is the forward and this is the reverse. And in this case, the ammonium ion is acting as the conjugate for reverse acid, as it's the proton donator, and the hydroxide is acting as the conjugate base. basically what we're saying here is ammonium and water have similar affinities for that hydrogen. What that means then is they can sort of play a little bit of tug of war with it. The ammonia can give the hydrogen ion to the water, and the water can give the hydrogen ion back to the ammonium, and they can sort of compete for it and form an equilibrium where the populations of each will balance out such that it's working in both directions. Same thing with fluorine. This is different from the strong case like HCl, where water has much more of an affinity or much more of a attraction for that hydrogen than does the chlorine. So once that water steals that hydrogen from the chlorine, none of it goes backwards. In a strong base, something like sodium hydroxide, once these two ions dissociate to form sodium and hydroxide, they do not reform. This is a very soluble base. And what that means is no reverse reaction. And that's what makes this strong versus this, which has the significant reverse reaction, being weak. So again, to summarize it, strong acids and strong bases are simply acids and bases that form equilibriums with significant rates for both the forward and the reverse reaction.